All right, so we're gonna start this video right here. Okay, I'm sure that most of us know who Reese Witherspoon is, right? So you probably have seen her in what's the movie? Legally Blonde or Sweet Home Alabama. I never watched that movie yet. Maybe I'll watch it after this class, after this the whole course. Anyway, so she has a daughter named Eva down here. Okay, does Eva look more like her mom or her dad as her partner? I think she got a round face from her dad, and everything else from her mom. Her hair, her eyes, her nose, her mouth from her mom. That's what I think. Okay, all right. I want to bring you to this. Who do you look like more, your mom or your dad? Well, we know that offspring or kids, right, possess some characteristic from your parents. Okay, maybe not the whole set, but at least you might got your eyes from your mom's, your hair from your dad, your ears, your nose, your body, maybe from one of your parents, right? The question to you is, what dictates whether or not you will look like your mom or your dad? What control that? Have you heard about dominant genes and recessive genes? Right? Yeah, you will possess the characteristic that which is gene that dominant. Okay, to give you some example, if your mom have a dark hair color, let's say black hair, your dad has a lighter hair, let's say blonde. Your hair tends to be on the darker side. Does it make sense to you? Yeah, dark hair. Usually, dark color is a dominant genes. Okay. Anyway, so genes control what you look like, correct? Molecules. This applies to molecules as well. We learned before that the real structures. We learned before that the resonance structures, none of them are real, but each one of them contribute to a real one, to a real structure that we can't draw. That's the limitation of bond line structure, right? So for in this example, we have this compound got two resonance structure. None of them are real, but these two together describe what the real compound looks like. Okay, but here's the thing though, these two don't contribute equally. This compound will look more like one or two. What do you think? Or how do you know? All right. How do you know? Well, the real compound will look more like the most stable resonance structures. What do we mean by the most stable? Let's take a look at compound 1. Do you see the carbocation? This guy is under octet. It's not octet, right? Doesn't have 8 electrons. And you guys know that's not stable. Versus compound 2, all of them are stable. All atoms are stable. That's a more stable resonance structures, which means that the real structure will look more like compound 2 than the compound 1. Okay, we call it major contributor. Then this one is a minor contributor. Right? Now, how do you know which resonance structures is a major contributor? Well, we check the stability, right? Here's the criteria. All atoms are octet. We prefer a neutral compound over a charged compound. Right? In case that we have a negative charge in a compound, we prefer the negative charge on an electronegative atom, which makes sense. Electronegative atom love to have electron, pull electron to itself. All right. All right. Let's go back to the resonance structure that you drew earlier in the previous video. All right. This compound have two resonance structure. Which one is the major contributor? Who's more stable? Of course, the charge, all atoms are octet. All atoms are octet, but this guy doesn't have charge. The real compound will look just more like this guy. Okay? All right. Now, next compound we have, there are 4 resonance structure. Which one is the major contributor? The most stable one, this guy right here. All right. So, charge, the rest are charged. This guy is a neutral. Okay. Now down here, who's major contributor? Gotta be the first one as well. First of all, neutral compound. The rest have charges, right? And you see the carbocation. Those are not octet. Okay. So the first resonance structure is octet. So the real molecule will look more like the first compound. The first resonance structures. All right. Come down here. What do you think? Again, still the first one, okay, neutral compound, and all atoms are octet. Down further, watch out this one. Who's the major contributor? Tick tock, tick tock. The last one, okay? The only reason is all of them have charge, doesn't matter. But these guys are octet. All atoms are octet. The rest have carbocation, right? Oxygen right here with the charge is still octet. If you count the electrons, 1, 2, 3, 4, 5, 6, the lone pair, 7 and 8. Yeah? But the carbocation here, and here, each one of them got only 6 electrons. All right, which means that the real compound is going to look just more like this guy. Okay, all right, let's go to the next video.